Welcome to the Rich Report, a podcast with news and information on the world of big data. Today, my guests are from Treasure Data, and we're going to start out with Kaz Ohta, the CTO of the company. Kaz, welcome to the show today.
Yeah, thanks, Rich, for having a podcast with us today.
Well, great. Kaz, why don't you introduce your colleagues there on the other side of the phone?
Yeah, here we have Kiyoto, VP of Product, and Ankush Rustagi, who is our Director of Marketing here.
Well, great. No, we were talking before the recording started. You guys have some background in HPC, but what you guys do is cloud-based analytics. And I was thinking, why don't we go through your slides and then I'll do a Q&A after that. So does that sound good?
Sure. So Treasure Data is a cloud data platform. We founded this company to deliver big data analytics in days, not months, without any specialist IT resources. And to do that, we have an infrastructure and then offer our service as a purely subscription-based model. So our customer can pay for us for like monthly revenue, monthly fee. And Treasure Data founded 2011. And lucky us, we have more than 80 plus customers, including Fortune 500 companies. And right now, we are storing more than 700 plus billion records across all the customers. And we have a wide variety of use cases from several industries, such as automotive and social and advertisement and digital marketing, and also the telco companies. And we have a world-class team. Our CEO, Hiro, was working at the company Red Hat, and he actually saw how the open source software penetrated into the enterprise. And Kaz Ohta was previously a HPC researcher, and I was part of a team of the Argonne National Laboratory, who has a supercomputer called Blue Gene. So I was a part of a team to provide a scalable I/O infrastructure for the Blue Gene supercomputer. And at the same time, I got naturally interested in another parallel I/O system called Hadoop, maybe 5 or 6 years ago. And I started writing article about Hadoop and then start organizing a community. And it's like 20, 30 people, nerd community. Now we have more than 1,500 people there. And lucky us, we got a lot of interest from investor base, and we have Jerry Yang, Yahoo's co-founder, as our backer, and Heroku, which is acquired by Salesforce, the platform as a service. All of the Heroku's founders are our backers, and Ruby Creator Math is also our backers. And recently, we closed a round with the venture firm called Sierra Ventures, who invested into the Teradata and Glimpram before, and a gentleman called Tim Grelly, who was the board member at Glimpram, joined us as a board. So that's the basic overview of our company and the team. So the problem we are solving is what I saw within the Hadoop community. So, and the biggest problem, it takes too long to get the system live, the data analytics system live, because of the shortage of the specialists. And in the market, there's a lot of complex solutions such as ETL, Hadoop, EDW, and NoSQL, but people actually don't know how to combine it because each component is too complex. And another problem is the data collection. So according to the one famous consulting firm, 60% of the BI project is actually consumed for how to collect the data. And I've seen a lot of cases for big data project that the data collection was a huge problem. And I want to describe more about this problem in the figure at the bottom. So y-axis is the customer value, and the x-axis is the time from the sign up or the start of the project. So if you go with the on-prem solution, you need to buy hardware, install software, do some tuning, and some POC, and finally you got a value from the system. But the hardware gets older and older and older, so you need to upgrade at some point. But now we have AWS, but they are more for Lego block, like component-based approach. So they have S3 for the storage, EC2 for compute, EMR for Hadoop, Redshift for data mart. So they need to combine all of these components, and the user still needs to maintain these systems. So Treasure Data's vision is provide a fully integrated big data full stack as a cloud, so that our customer can immediately put the data into the infrastructure and then start analyzing the data. We also provide our service as a cloud service so that we can improve as time goes. So this is our vision. To achieve this vision, we have a current product which consists of 3 components. One is the data collection, and second one is data warehouse on the cloud, and third one is the BI connectivity, the data analysis part. And obviously at the center, we have a data warehouse component. We built our own columnar storage on top of the object-based storage, which achieves a lot more compression and the performance. We're also using Hadoop MapReduce to process hundreds of billions of records. As I said, we are now storing more than 700 billion records within our columnar storage, and also importing more than 100 billion records across the customers per month. But the biggest question is how to move the data from customer side into the cloud side. And there's a lot of variety of data sources such as web logs, application logs, sensor data, RDB, CRM, ERP data. So we categorize these data sources into 2. One is more for semi-structured, unstructured data, and more for structured data. And for unstructured or semi-structured data, we developed our own load collector called FluentD, and then make it open source. And we've got a lot of buzz around FluentD, and fortunately, 2,000 companies, including SlideShare, LinkedIn, are using it. So FluentD is a general-purpose load collector, which takes data in and buffers it and then stores it to somewhere, which is really similar architecture. I was working at the Blue Gym. They have also I/O forwarder, which takes data in, buffer it, and store it somewhere, and which is more like FluentD is more lightweight mechanism. So FluentD's user actually choose the backend storage so that you can store the collected data into whether MongoDB, MySQL, whatever. But if you install one plugin, you can actually upload the collected data into the cloud, and this is a kind of streaming upload, so that customer can query against that data nearly real time. And for structured data, we have a bulk loader which takes CSV and TSV as an input, so that we can upload the dump data into the cloud in pieces by the parallel upload feature. And once the data is imported, we have a REST API which takes the SQL and pig script, and we built our own JDBC and ODBC driver on top of this REST API, so that our user can query from the existing BI tool. We can also push the query result to the customer dashboard or FTP server or whatever, because in most cases, customers already have their own in-house dashboard, the kind of thing. And the point here is that our biggest differentiation is providing the whole data pipeline from data collection, data storage, data processing, and BI connectivity, so that our customer can instantly implement the big data infrastructure. So by looking at our customer, the average the project time to integrate with our service is 2 to 3 weeks, which is tremendously short compared to the normal Hadoop and big data project. And by the way, we are multi-tenant architecture, like Salesforce.com and Heroku, meaning we are running the single software instance for all the users, which gives us a lot more speed of improvements and ease of management of the infrastructure. And I want to show you 3 customer use cases. The first customer use case is a company called Mobfox. Mobfox is Europe's largest mobile ad exchange, serving 20 billion impressions per month for 15K mobile apps. And they have their own analytics and reporting infrastructure, but it didn't scale really well. So they need to build something scalable ASAP. So they found trade data and got into production only in 14 days by one engineer. And the figure shows how they did it. So they have hundreds of PHP application servers which serves ad requests from iPhone, Android, PC, BlackBerry. And at the bottom, they have a dashboard for publishers and advertisers which accesses to the local MySQL, which stores the data mart. So what they did at week 1 is they installed TD Agent, which is a Fluentd's enterprise version of a package, into their on-prem data center. And then tweak some lines of code to record all the impression and the click logs. After that, 20 billion impressions per month are streamingly uploaded into Treasure Data every 5 minutes. And because they have hundreds of servers, this change took a week. And at week 2, they started periodically query against the stored data and summarize and aggregate and then create the data cube and then put the data into MySQL. So the point here is that the front-end PHP application, dashboard, and local MySQL is actually almost unchanged. They just install load collector and query against it, and then just replace the backend. And they actually now have more than 40 billion impressions per month, 2x compared to the previous quarter, but they have no trouble of managing the infrastructure. And I want to go to the second company's use case, page 6, and the company called Wiki. It's kind of global Hulu-like online video services with millions of users. And their contents are distributed over 150 languages. So before having Treasure Data, they have 3 problems. First, they don't know how to collect data robustly and scalably from multiple devices or multiple locations. And they have their own internal Hadoop cluster, but at the end of the day, their engineers want to focus more on building than managing the infrastructure. So they had also a hard time to manage the Hadoop cluster. And they also wrote the custom script, which put the query result of Hadoop into the PostgreSQL, but it failed occasionally and reboot are broken at that time. So after having Treasure Data, they deployed TD Agent or load collector into Heroku environment, and then records all the user's behavior, such as clicking the video player, move the slider, whatever. And then they streamingly upload the billions of records into Treasure Data. And Treasure Data is a cloud-based maintenance-free service. And we also have a reliable direct insight feature into the PostgreSQL. So this is really similar to what Mobfox did. And I want to introduce third example, page 7, the company called Getcha. So Getcha is the world's largest Android application market, serving 3 billion apps, downloads for 100 million users. They only have one engineer managing the data infrastructure. And what they did is installing the TD agent within their on-prem. They already had a load collector called Scribe, so they piped the collected data from Scribe to TD agent, and after that, the collected data is streamingly uploaded into the Treasure Data. And they periodically query against Treasure Data, and they put the data cube into the local MySQL as a data mart. And they're using Tableau, the really famous BI tool, for the visualization. The point here is that all of these companies, 3 companies, just install load collector and query against it so that they can achieve to store and process more than billions of records, almost by one engineer within 2 to 3 weeks. So that's the point. So this is the overview of our company.
I'm curious about these use cases. Are they continually feeding data to that database at your
Yeah.
cloud center?
So what we notice is that there are essentially two types of data: the data that they already have, and the data they haven't been able to collect. So for the data they already have, that we have a bulk importer tool. But for the data that is more like a streaming data, this is where they use a TD agent to continuously upload their data into our backend system.
And then you mentioned the mechanisms you've developed to get that data moved, right? Because it's very difficult to move petabytes across the network. Do you have a physical infrastructure you can use as well, like a FedEx kind of a way to get the initial setup going?
I know I'm talking to an expert when you point that out. Yes, it is a huge problem, and by far, like, it is the most laborious, time-consuming part of it. We don't do anything like FedExing data and like a hard drive and like uploading it ourselves yet. It is still over the internet, so it is only as fast as the bandwidth that you can afford. That said, we were very careful to architect our bulk loader so that if anything goes wrong during the upload, it makes it very clear to our customer so that they can retry. Because the last thing you want from data is missing it or missing parts of it and basing your important business decisions on data that is not correct. So all of our systems, like both our bulk importer as well as the streaming data collector, they really care about reliability, and we take a lot of we base a lot of our architectural decisions to favor reliability above all.
Yeah, when we upload the data, we do compression and the SSL protection, that kind of thing.
So you take away these pain points, right, of setting up your own data center to run Hadoop, and you also know how to make it run quickly. What do you think your advantage is there as far as speed of processing and the way you've architected this?
Yeah, so I think our speed comes in two forms. One is the actual performance is pretty good thanks to our proprietary data storage system called Plasma, which is column-based and distributed. But also, the other aspect of speed is agility. Sure, like you can build your own system, you can spin up your Hadoop instances, but they tend to take months, if not up to like a year or two, with an army of experts behind the project. With Treasure Data, from signing up through our web interface to actually getting the data into our system and having a live system in production serving your customers, it's usually from 2 to 3 weeks. And a lot of our customers resonated with this agility aspect of our service.
Yeah, I mean, I could see this from your case studies there. You've got, basically one engineer, you're turning him into kind of a hero that he is able to do this by himself. And was that the idea from the beginning to empower smaller groups to do big jobs?
By running the Hadoop Unity, I've seen maybe more than 100 Hadoop deployments, and then the biggest pain is they started using Hadoop, but one of the things that is most difficult is just keep managing the Hadoop cluster, right? That requires the knowledge of the hardware, how CPU memory works, the network, how the network shuffle occurs, and the JVM operating system kernel, within the kernel, and then finally Hadoop, and it's also a distributed system. So to maintain the Hadoop cluster, you need all of these knowledge, and there are rare. It's really rare to find that kind of people. So people actually stopped using Hadoop and switched into other expensive data warehouse, whatever. So that's why I really feel like this is really a chance. So by providing the cloud-based service, we can actually leverage that point to several customers, meaning providing a single services into multiple customers at the same time, and then solve all of these data points. Yeah. So that's from day one.
And you mentioned you're providing this in a monthly kind of subscription. Does that vary by the size of the data, or how do How do you
Yeah.
monitor
So
that?
our monthly price is based on storage and compute power at this point.
Yeah, and the real upshot of our monthly subscription plan, as opposed to, I'm not going to name names, but a lot of other services where you are expected to make a huge initial investment, is that you can try it for like a week or for two, or run it in production for 1 month, and if that doesn't work out, like there's no there's no reason why you can't just like terminate your service there. But also, if you like our service, you can start very small. And as your data increases, you can spin up more instances. You can increase your storage limit, and of course, we'll charge you more if you use our service more. But we want to be very flexible in how we price our system and make it very elastic.
Oh, terrific. Well, guys, I got kind of a wrap-up question here. What kinds of capabilities are your customers asking for that might give us a glimpse into the future of this kind of technology?
We're working on two major projects. One is making our queries faster. This is always the customer's request, right? I'm happy with their service. I'm even happier if I can get my answers faster. So we're working on a project to make our queries run faster, anywhere between 5 to 10 times. That is still up in the air. The other aspect is that we want to enrich our visualization layer. And as Kaz talked earlier, we have great connectivity to existing tools. But sometimes our customers do not have any incumbent visualization tools. But even for those customers, we want our platform to be useful, like immediately useful and valuable. And in order to do that, it is tremendously helpful for them to have an out-of-the-box visualization solution so that they can sign up, start collecting data, and bang, they can just visualize data from day one.
Well, terrific. Well, gentlemen, I want to thank you once again for coming on the show today. Sounds like the future is very bright for treasure data.
Thanks a lot, Rich. Thanks for having us today.
You bet, you bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of big data.